My name is Austin Hounsel, and I'm a PhD student at Princeton University, presenting some work today on designing for Tussle and encrypted DNS. This is some work that was done in collaboration with Paul Schmidt, Kevin Bargolta, and Nick Feemster. So let's get right into it. So up front, just want to say our contributions. So we are framing the debates over centralization in the encrypted DNS ecosystem as a tussle space. And by that, we mean a space in which various stakeholders, whether it's ISP resolvers or major DNS providers, are with competing interests, are shaping internet protocol design, particularly for encrypted DNS and its deployment. So we explore how the DNS infrastructure might allow these tussles to play out such that all the stakeholders have some kind of voice over how DNS resolvers are selected and the ways in which DNS queries are distributed, and empowering users to make these decisions themselves. We present the design and prototype implementation of a refactored stub resolver that implements these principles for decentralizing encrypted DNS queries. So key takeaways from this are that DOE resolution should be handled, in our opinion, by a single application on behalf of an entire device, such as an operating system stub resolver. Clients should not only be able to express meaningful preferences to these stub resolvers, such as don't use my ISP resolver or only use my ISP resolver, but also things like I want to avoid resolvers that use a particular geographic region, right? So really, we want to empower users to be able to have more control over how their queries are sent to various resolvers. And not only should they be able to express preferences about which resolvers they would like to use or like to avoid, but also specify methods to distribute queries across multiple resolvers so as to reduce centralization. And I'm going to go a little bit more later about the technical details of how we do that. But just to provide some background first, we want to note that DNS-over-TLS, as I'm sure many of you know, has become a significant concern in the past couple of years, whether it's on-path network observers being able to infer which websites you're visiting by looking at plain text DNS traffic. It's going to occur on many different kinds of networks. And in response to this, we see that two protocols have been proposed and standardized over the past couple of years. That's DNS-over-TLS or DOT, and following that, we had DNS-over-HTTPS or DOE. And we're seeing that increasingly, these encrypted DNS protocols are being rolled out and being implemented by major applications such as web browsers. You know, Firefox, Chrome, Brave, Edge, Opera, they're all implementing DOE and providing users with some selection over which DNS resolvers they can use. However, at the moment, most of these lists of resolvers are fairly small. And we're seeing that there's been increasing concern within the networking community and the networking standards community over centralization of DNS, in which people are concerned that the default choices that are being made by major applications that deploy DOE are causing users to not only centralize their queries into a small handful of resolvers, in which the ones that support DOE, but also we're seeing that people feel like there's concern in the future that increasingly their DNS queries might be mishandled, or that there might be other concerns about further centralization. So there's really two research questions that we have. One of which is more so something that's open for discussion, and I'd love to hear your feedback on this, which is that, is decentralization something we want to do in the first place? And what I mean by decentralization is, do we want to design the DNS in such a way that there are technical means for which we can avoid DNS centralization, such as by distributing queries across multiple resolvers instead of sending all queries to a single DOE resolver? What we're focusing on in this talk is it technically possible? You know, what forms could decentralization take? What different strategies could you use to distribute queries separate from whether or not we actually want to do decentralization? And there are several principles that are guiding our design of a technical architecture for decentralizing the DNS queries. Excuse me. One is to design for choice, and that is to say that users should always be in control over which DNS resolvers their computer are communicating with, right? And this seems like a fairly straightforward principle, but we're seeing that whether it's in certain IoT devices or certain applications, that there are often hard-coded lists of resolvers or a single resolver by certain applications, and clients have little understanding over how to configure these options, what the DNS even is. And this is very much impacting the way in which their queries are being handled and in turn their privacy. We also note that we don't think clients that implement DOE should assume the answer. right? So application and devices should enable users to express various preferences about which resolvers they would like to use rather than providing a predefined list, right? And using that list for all clients. So for example, if a local resolver has been discovered on the network that supports DOE, clients may wish to use that resolver when it's available. They may have more trust in an ISP resolver. On the other end, some clients may not trust their ISP resolver and may wish to use a major provider like Cloudflare or Google, for example, right? So in short, clients should always be able to express some kind of preference about, I want to avoid this region, I want to avoid this provider, or avoid this network, right? And lastly, we think that the DNS should be designed to modularize across tussle boundaries. And what we mean by that is that, if each application is handling DOE resolution in their own way, then users won't be able to have a very consistent way to configure how they want their data to be handled and sent on their device. So we think that DOE resolution should return to the role of an operating system stub resolver rather than being handled in various different applications in which users may not even be aware that encrypted DNS resolution is happening, much less which resolvers are being used without having to look at network traffic. And these are principles that were inspired by a Clark et al. Paper. I want to make a note of tussles in cyberspace defining tomorrow's internet. So what does this look like? What does a technical architecture for decentralizing DNS queries look like? So, and enabling various stakeholders to have a voice. So we envision something fairly simple and almost a return to form in terms of networking in the past, but we think it's important to state what it is exactly that we think we're accomplishing here. So the stub resolver, acting on behalf of the operating system rather than an application on a device or various applications, discovers various resolvers that support DOE, whether they're on the local network from a predefined list or other out-of-band means of retrieving a list of resolvers. The user then articulates requirements for which resolvers they would like to use or not use, such as a preference to avoid a specific geographic region, a preference to avoid specific providers, whether it's ISP or not, major provider or not. The user should be able to specify, if they desire, which resolvers they would and would not like to use. And then among that list of resolvers, these queries could then be distributed across multiple of them according to some user-specified strategy, right? So instead of all of the queries being sent by default to a single provider, whether it's your ISP or not, your queries can actually be distributed in some strategy across various resolvers so that no one resolver has access to all of a client's DNS queries, which we think is increasingly becoming a concern. So we prototyped this stub resolver through forking the DNSCrypt proxy resolver, which enabled us to add support for hash, round robin, and random query distribution strategies, which I'm going to go a little more into in a second. We've made our code, our fork of the proxy, publicly available at the link below. So in the hash distribution strategy, it's fairly straightforward, you might imagine. We take the second level domain name, hash it, and use it as an index into a list of resolvers, right? So in the case of example.com, it gets hashed, indexed into a list. Let's say it goes to Cloudflare. Images.example.com, since it's just a subdomain, would also go to the same resolver so as to ensure that each resolver has as little information as possible about the traffic patterns of a user. Then another query, two queries go to New York Times, go to Google, and then Washington Post goes to Cloud9, right? So we're seeing the queries being split up according to some strategy. Round robin, also fairly straightforward, you might imagine, just sequentially distributing queries across resolvers. So first one goes to the first resolver, second query goes to second resolver, third to the third, so on and so forth. And then the random strategy, again, fairly intuitive. Each query is randomly distributed to a different resolver. So the same query for the same domain name could go to two different resolvers, which may not be seen as beneficial in terms of privacy, but this is just a very simple strategy for demonstration purposes. So in summary, we frame the debates over centralization in the encrypted DNS ecosystem as a tussle space with various stakeholders competing for access to queries for different reasons. We talk much more about the actual tussles in our full paper, I should note. We explore how the DNS infrastructure might allow these tussles to play out such that each stakeholder has a voice and has the ability to express preferences, and including users have the ability to have the power to decide where their queries go. And we present the design and architecture of a stub resolver that allows for this kind of decentralized DNS resolution.